Well, good afternoon. This is the second video in the repair process for the 3335A. And in the previous video, we discovered that the power supply was being dragged down. So let's just take a quick look at that again. And to do that, I'll plug the unit back in. I'm unplugging the unit a lot because the power supply up here, if we move that in, this is always left on. And the reason this is always on, partially, is because it's going to feed the temperature-controlled oscillator over here to ensure that we still have the right, that it's always warm, and so when we fire up, it's ready to go. So what I'm going to go do here is just hook in, and we're using the case for as the ground. Okay, now these are our pins here, and so we can see the output there. Let me turn that on, and what we'll notice here, this is supposed to be, let me put my glasses on, it's supposed to be minus 5.2, and you'll see that's minus 3, this is supposed to be plus 15, this is supposed to be plus 5, and this is supposed to be minus 15. So all of these powers are clearly incorrect because they're being dragged down. Now, one of the things that we can do to see, the first step to see if the power supply is working correctly is to take a look at the rectifiers. And these are the rectifiers here. And so if we come in, and again, let me put my ground on. And now if we have a look on the, let me see if I can get that over in, and we might see if we can get closer in on that. Just zoom in a bit. Let's, yep, dropping stuff left, right, and center. So over here, what you'll see, let me move that out of the road. Let me get my little pointy stick. On here you can see, and let's zoom in just a bit more. See if we can get in there. You can see that there is a plus symbol and a minus symbol. So I think you might be able to see it. Plus and a minus symbol. There's minus here. And then you can see the two wave symbols showing that that's where the AC's coming in. So we'll get whatever the voltage from the tap from the transformer, we'll get a plus and minus and positive and negative voltage for that. So that's a good way for us to see the basic operation of the regulators. Now, as I said, these regulators are always on, so we don't need to actually turn the unit on to measure that. So let's have a look at this first one, and you'll see that we're getting 10 volts there, and on the second one, we're getting 22, 23, minus 24. Now, these are supposed to be a plus or minus 10, a plus or minus 8, sorry, and a plus or minus 20 unregulated voltages. And the margin on this is available to be plus or minus 20%. So 10 volts is a little high for the 8 volt line, but 24 volts should be fine, close enough for the 20 volt. So overall, that value there is not out of whack. So we're getting unregulated values of enough voltage for us to regulate down. Let me just take a quick drink. Here we go. It's Sunday afternoon here, and that is the drink of choice is an apple cider. Washington State is one of the top apple producing states in all of the US, as a little fact. Anyway, what we can do now is we can start looking at the two power supply cards here. This is basically the power supply card, and then this card in underneath it here, which we can't quite see. Let me move my DMM out of the road, and we'll tilt it up a little bit, and you might be able to see it just in there. That card is the pass transistor. card. So how the power supply works is to basically feed the unregulated voltage through the pass transistor card and back into the power supply here, and then from the power supply card into the rest of the unit. So what we can do is measure the voltages that are coming in here when we unplug the rest of the unit. So the two jumpers that connect to the rest of the unit here are jumper 2, which is this guy here, and if we look at this wire, it goes down here and into the middle of the unit, and that is feeding the motherboard here for its voltages. And then this jumper here, jumper 4, that's jumper 2, jumper 4. And if you look at this guy here, that drags all the way around over to the front panels here and feeds in the front panel. So let's just go in and make sure I remove the connectors, and we'll just pull these guys out. Now that we've got these guys out, we should be able to plug this back in, turn the unit on, and measure the power that's coming off this connector here. So let's go and do that. We'll bring this guy back in here. We will reconnect my ground. And now let's measure the voltages that are coming in. Now the first two should be 0, which they are, because they're going to be the black ones. So now the next ones are going to be minus 15 volts. And so we can see minus 15, minus 15 and minus 15 there. So those two things, which are the two blue, are correct. These guys is plus 15, plus 15, so they're good. The yellows are going to be minus 5.2. They're a little low. They should be minus 5.3 because they have to account for some loss in the signal. And then the final guys out here are going to be the 5 volt rails. And they're a little, that one's a little high there. But we're reading the correct voltages here. So I think what is going on is there's a problem in the units over here. So let's turn this off for a moment and take a look at where I think the problem might be coming from. Now, I went out and I read, looked into the in the instruction manual, in the operating manual, and this here is what I think from reading the schematics. This is where I think the problem exists. Now, let me just zoom in a bit here so we can see this. What we're seeing here is this part of the circuit is the power supply. It's the power supply board and the pass transistor board. And those jumpers, jumper 2 and jumper 4, connect through to the motherboard, which is that where I measured the voltages before. And on this motherboard, what we can see here is that there are numerous bypass capacitors on each line. And so what I suspect has gone on is that one of or more of these capacitors have died, and they're dragging that line down. So the next step is to go in and remove all the cards from the unit and see how, see if we can measure the voltages again on the motherboard. And if the voltages are wrong because of the motherboard, that will be because of those decoupling capacitors needing to be replaced. But if it turns out that the voltages are actually the same as what we're seeing over here, on the motherboard, just here, then what it's telling us is that one or more of these cards has gone kaput and is dragging the voltage down. Now again, each of those cards will have the coupling capacitors spread throughout them. So the first step is for us just to remove all those cards. So to do that, what I'm going to go do is I'm going to just plug these connectors back in, and I'm just going to go and remove this centerpiece here. So let me grab a a spanner. Yep, so there we go, one there. Now, if you look, and if we zoom in a little bit, you can actually see there are marks there. So I suspect that somebody's had this thing out before at some point. And so there's probably either somebody's had a try at fixing it, or maybe it was doing something intermittently, and then they said, well, okay, what we'll do is we will take it out, see if we can diagnose it, and they weren't able to diagnose it, and that's what's bent those pins, you know, when they were taking this thing in and out. If you remember, I showed the pins being bent on the, there we go, on the controller boards. So, okay. Okay. Now, in the other units that I've played with, these cards have been mounted vertically and the motherboard's on the bottom, so it's accessible by just simply taking the bottom plate of the device off. But clearly, that wasn't what HP wanted to do when they made this guy. Now, if you look here, what we've got is we've got a little piece of hardline coming over there. So let's just unscrew this guy. Okay. Ooh. Well. Huh. I don't know if you can see there, but you see there's a little angle on that? Looks like that's gotten cross-threaded somehow. Wow. Well, I hope that hasn't impacted. Oh, there's my dogs. Hang on. I'll be right back. Okay, we're back now. It was just some people moving around outside. So let's see if this thing will come out now. Okay, now I have to, oh, yes it does. Okay, now, if you actually take a look, I don't know if I showed this, but you can see there are actually 4 little legs here on the backs of the unit. So I'm guessing this is meant to actually just sit, you know, you can put it back down in here. Well, actually, there seems to be enough thing that we could take this out and put this on the bench. Wow. Well, there you go. Okay, now that we're back out again, notice something else on the unit. If you look here, one of these wires is either not connected or is broken out. Now there we go, we see one right there that isn't connected. So I wonder if that also has something to do with the lack of the device working. So it turns out that this wire was actually, this is a W7 wiring loom. This thing was actually inserted incorrectly. It was back to front, so it was transposing pin 1 and pin 18 on the A10 board with the A1 connector. And they really should have just been straight pass-through. So when I turned the connector around, it actually aligned that broken wire with a ground. And so I don't think the wire will actually cause that much of an issue. The downside is, though, that with this being around the other way and with the way that the boards are designed, there might have been a chance that it's just blown a bunch of the boards and a bunch of the ICs. So this unit may just be completely dead. Anyway, let's keep going and we'll see what happens. Let's take a quick look at the other wires. Okay. So now this is pretty much that standard look. If you've seen the other videos I've done, where the cards will be stacked up. So what I'm going to go do now is just take these cards out. So let's just grab here we go. Let's grab my Posi drive screwdriver. We'll take one card out and then you can have a look and see how that goes. And then I will take all the cards out and we'll try powering up the unit. You can see there is a bunch of screws missing. So somebody's had this unit. This unit may just actually be completely cactus. Based on the fact that it's got so many screws missing. With so many screws missing, they might have already tried taking this apart to repair some other problem. So the power supply may not actually be the real issue here. You know, once we get it all working. So anyway, there we go. We've got one card done and we should just be able to slide that out. And there you go. You can see the typical card of the era. You know, we can see that the very, simple layout, a lot of ground plane, all through-hole component here, some custom HP parts. Let me take a look and see if anything is actually no, doesn't appear anyone's worked on this board. We can see some date codes here. 32nd week of 79, 43rd week of 79, 21st week of 79. So a lot of these, looks like this product was made in 79. Okay, well, with that, I will take out all the other cards and then we'll try and measure this again. Okay, so I have all of the cards out now, and in fact you can see a little bit inside here, and you can see that there's a bunch of ceramic capacitors in there for decoupling and so on. So if this is actually the issue, then I'm going to have to take these cans off to be able to actually get to those capacitors. Anyway, I'm hoping that, I looked at the boards and I didn't see any rework or anything done on the board, so I don't know what they were doing to scratch this up. So unless they've just been wholesale swapping boards from working units to bad units or so on, I don't know. Anyway, we have this plugged in, so let's turn this on. I have this hooked up, so now let's start and measure our voltages. Minus 5.3, minus 15, 5.1, minus 15. Okay. So what that tells us then is that the back plane, the motherboard, is going to be okay. So now what we're going to have to go do is look through the individual cards and see at each card which one would cause the problems. So what I'm going to have to do is basically, the easiest way to do it is to simply turn the unit on, well, plug in a card, turn the unit on and measure the voltages and just see what goes on. So to do that, what I'm going to go do is just clip in a voltage, clip in one of my probes here, and we'll just hook into the 15 volt there. So this, the 15 volt is the primary voltage that controls the system, because it's the sense line and so on that comes through the power supply. So now I'm going to go in and start plugging in boards, and we'll see if one brings up and shows us a problem. Okay. Well, I plugged the first board in and I noticed 9.5 volts. I thought, man, that can't be, I can't be that lucky. I can't have that as the first board. So then I started checking the other boards in here, and all of them exhibited, when only one board was in, they all exhibited a problem of not of a lower voltage. So let's just drop all of these guys back in. And turn it on again, and you'll see that we have the low voltage. So what that leads me to believe is that I've actually been diagnosing the wrong part of the unit. We get the voltages are correct while there's no load. As soon as we're applying load, the voltages are dropping down, which leads me to think that now what we actually have is a problem with the regulation in the power supply. So what I'm going to go do is I'm going to reassemble these, and then we'll take a look at the power supply and see if we can diagnose the problems in the power supply itself, and find out if there's anything wrong with the regulators. Well, that will be part 3 of the view. If you've enjoyed the process so far, give me a thumbs up. It helps with the rankings. If you've joined since the last couple of days, welcome aboard, and I hope you find some content that you like. If you have any questions, just drop them in the comments, and I'll try and answer them. Catch you later.